This is lesson 60. We're talking about the area of a parallelogram, and your objective is to find the area of a parallelogram using a formula. So the very first thing I want to do is talk about the formula for the area of a parallelogram. Okay, so here is a parallelogram, and you find the area of a parallelogram kind of the same way you find the area of a rectangle. Okay, it's the same formula. So the area formula for a parallelogram is the base times the height. Okay? Now the only thing that changes is to know what the base and the height of a parallelogram are. Okay? It is always going to be your bottom part. Okay? So bottom or top, I guess, are both the bases. So this is the base down here. Okay? Now the height is like when we talked about triangles. The height of a parallelogram, or the height of anything, has to be a line that goes straight up and down to form a 90-degree angle. Okay, well if I look at the sides of my parallelogram, these lines don't go straight up and down. They don't form a 90-degree angle with my base here. Okay, so our height is going to be an imaginary line that goes straight up and down. Okay, to make a 90-degree angle right there. So that is the height. Okay? Now we could also make a height going from the top straight to the bottom down here. That could also be a height. Okay, but notice that should be the same distance either way. If I drew one there, or if I drew one right here on the outside. Okay, but it's got to go straight up and down to be the height. Okay, so again, the height of a parallelogram is an imaginary line going from the base of the parallelogram straight up to the top. Okay, can't slant like this. So we always need to know to find the area of a parallelogram, the base and the height. Alright, so let's look at some. Example 1 says to find the perimeter and the area of this parallelogram. Okay, well first let's go ahead and find the perimeter. Remember, to find the perimeter, we just add up all the sides. So we're going to add up the actual 4 sides of the parallelogram, the outside. Okay? So the base is 8, this side is 6, and a parallelogram works like a rectangle. So if this side is 8, this side is 8, and if this side is 6, then this side is 6. Okay, so we're going to go ahead and label these as well. And our perimeter is going to be 8 plus 6 plus 8 plus 6. Okay, and 8 plus 6 is 14, and I got 2 of those. 14 plus 14 is 28 centimeters for the perimeter. Okay, again, perimeter never changes. You just add up all the sides. Okay, now the area of a parallelogram. First thing I want you to do is write down the formula. It's area equals, again, base times height. So our area is going to be our base of our parallelogram, which is 8, times the height. And the height is this straight up and down line right here that they give us, which is 5. Okay? So our area is going to be 40 centimeters squared. Okay, again, notice what numbers I used for the perimeter. I used all the outside numbers for the perimeter. And the area, just like we found the area of a triangle, okay, we use the base and the height, okay? And that's all there is to it for finding the area of a parallelogram. Let's go on to another example. Okay, example 2 says on a coordinate plane, sketch and find the area of parallelogram ABCD with the given vertices. Then after that, we're going to graph the dilation of the parallelogram with a scale factor of 3 and find the area of that one. And then we want to find out the area of the image is how many times the area of the parallelogram we started with and why. Okay, so I'm going to go on to the next slide on this. You should have this slide and the next one ready to go. Okay, so I'm going to do all this work on the next slide. The very first thing we need to do is sketch ABCD. And we got the vertices at 2, 1. So we got one vertice right there. And 1, negative 1. So we're right there. And then we've got negative 2, negative 1, which is right here. And negative 1, positive 1, which is right here. Okay, So here's our parallelogram, and we'll go ahead and connect. So there's parallelogram A, B, C, D. Okay? Now we want to find the area of that parallelogram. So for part A, the area of that parallelogram area equals base times height. Okay? So we need to know how long the base is and how high the height is. Okay? Well, the base of this parallelogram is from C to D. Here we go 1, 2, 3 spaces. Okay, so the base is 3. Oops, I want to erase that, sorry. Make it my thin pen again. So the base is 3, and the height is the straight up and down line. And that's 2 squares. Okay? So the area is the base times the height, 3 times 2, which is 6 units squared. Okay? Now part B says we want to graph the dilation of the parallelogram with a scale factor of 3. Okay, so a scale factor of 3 means we want this to be 3 times bigger, okay, than this other parallelogram. Okay, so if we want this to be 3 times bigger, then the very first thing I'm going to do is write down what my A was here. Okay, so my A, again, was 2, 1. My B was 1, negative 1. My C is negative 2, negative 1. And my D was negative 1, positive 1. Now, if we want the image to be 3 times bigger, then that means every one of these coordinates needs to be 3 times what A was. So my dilation I'm going to call A prime. Okay, now A prime, the x part needs to be 3 times bigger, so 2 times 3 is 6, and the y part needs to be 3 times bigger. 1 times 3 is 3. Okay, B prime needs to be 3 times the x and 3 times the y, so 3 times 1 is 3, and 3 times negative 1 is negative 3. C prime is going to be 3 times negative 2, which is negative 6, and 3 times negative 1, which is negative 3. And then D prime, again, scale factor is 3, so each part needs to be 3 times bigger, so negative 1 times 3 is negative 3, and 1 times 3 is positive 3. And then I'm going to plot those points. Okay? So we're going to have a new parallelogram. A prime is at 6, 3, so I need to go 1, 2, 3, 4, 5, 6, and up 3. That's right there. Okay? B prime is at 3, negative 3, so I go over 3 and down 3, so we're right there. C prime is negative 6, negative 3, okay, which is right here. And then D prime is negative 3, positive 3, which is right here. Okay? And then I'm going to go ahead and connect those to make my parallelogram that's 3 times as big. And this is A prime, B prime, C prime, and D prime. Okay, so the area of my dilated part, well, the first thing I need to figure out is how big the sides are. This base here is 1, 2, 3, 4, 5, 6, 7, 8, 9. And the height right here is 6. Okay? So for part B, I got the area is the base times the height. And that's going to be the base is 9 times the height is 6. So that's 54 units squared. Okay? Now part C asks, the area of the image is how many times the area of the first parallelogram? And the answer is, well, how many times bigger is 54 than 6? That's 9 times bigger. Okay? And the reason for that is because when we have a scale factor of 3, okay, we tripled the base. It went from 3 to 9. And we tripled the height. It went from 2 to 6. Okay, so if we triple the base and triple the height, that means we had to take the area, 3 times 3, that's 9 times bigger. Okay? Alright, so that's your lesson on the area of a parallelogram. Good luck on the homework example now.